Hi, check it out. This is the Tandy 102 portable computer, one of the world's first and most popular portable computers of all time. This is the upgrade to the classic Tandy 100 from 1983. This is the 102. Dates from about, this model came out in 1986, and it's identical to the Model 100. It's just a little bit thinner and lighter. And anyway, this was basically the most popular notebook computer in the 1980s. Had a modem built in. Every single reporter, journalist had one of these things because they could type up their stories, connect it to their acoustic coupler modem, and then dial back in and send their story back to the news desk and stuff like that, let alone countless other uses. But I've done a teardown video of the original 100, but I also have a Tandy 102. We can see some classic yellowing of the bromine in the plastics here. It's a fire retardant. It causes them to go yellow over time, and that's fairly typical. But anyway, I did a teardown of the 100. This is the 102, and it used to work, but it's now got a rather unusual fault. So let's take a look at it and see if we can fix it. Oh, and by the way, the Tandy 100 is famous for being one of the last computers actually containing significant code written by Bill Gates himself. So he actually worked on the ROM for this thing, so the original Tandy 100. Anyway, let's switch it on, and you can see it appears to actually work. Copyright Microsoft, text, telecom address. It had like a spreadsheet, a word processor built in, and basic built-in and everything. But you can see up the top here, there's something weird going on. It's like there's, look, you can see the clock up there. It's here 54, 55, 56, but it's all sort of weirdy. Something's going on. This doesn't look correct. And, well, let's go into the basic here and let's have a look. Model 100 software. Once again, this top corner up here, something weird is going on. We've got two flashing cursors. This should say, something bytes free, right? I don't know I can't remember how much memory's in this one, but yeah, something has gone wrong, and Microsoft, what's all this going on? Something weird. Right, let's clear this, okay? So everything looks to be working just fine and dandy, but let's have a look what happens here, okay? What I'll do is I'll just 1, 2, 3, 4, so everything seems to be working, 5, 6, 7, but watch this. We go to 8. Oops. Once we went past 8, the cursor has wrapped back here and it's starting to overwrite. So 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, and it just keeps overriding like that. And it's no coincidence that it's doing it after the 8th character. So, because, there'll be an 8-bit bus, it's shifting, whatever, it might store one column or something as a byte, or, whatever. It's no coincidence that the number is 8. And if we go down here like this, you can see once we get actually down to the 5th line down here, the cursor wraps up here and it duplicates anything on the 5th line, and then it duplicates anything on the 5th line, on the 1st line, and then once again continues to wrap. And if we go down another line, it'll duplicate it. So the 8th line down here, it'll duplicate it on the 4th line. Isn't that fascinating? So there's obviously something to do with how the data is getting into the display drive. The display drive is obviously working because the correct characters are showing up. It's basically garbage in, garbage out, pretty much. So the actual column and line drivers and everything else of the LCD seem to be just fine. So we can pretty much rule out that as an issue. It's the data being fed into them. And this LCD is going to have multiple driver chips for it. There's probably going to be one chip controlling the first 4 lines here and the first 8 characters. And they've probably got another chip controlling that one. So it's probably that chip up there that's causing some sort of issue. Anyway, luckily, we do have the schematics. Schematics! I need schematics! For those playing along at home, this is 1986, 10th month, I presume. I presume that's a lowish serial number. If anyone knows, please let us know. Product of Japan, all the best stuff's made in Japan. Oh, and if you don't know, it has a memory protection switch because this didn't have any of that non-volatile rubbish. It was volatile SRAM. It kept your program in when you switched it off. So good old SRAM. And yeah, you could protect that or not with your batteries. And there we go. You can plug in expansion RAM there. So that looks like it has an additional 62256 in there. Oh, okay. Other stuff if you haven't seen it. RS-232 serial, a system bus connector, a printer connector, the phone. That was your modem because it does actually have a proper isolation transformer in there, and your cassette tape storage. It had a light pen, good for like inventory control for warehouses and stuff like that. That's the direction answer originate. For those who are used to your modem sex, you'll know all about that. All right, I think I've got this mostly off. That should lift off. We're in like Flynn. There we go. And the keyboard on this feels beautiful, by the way. It's just, it's fantastic. So there's our LCD up there. Whether or not we can get, oh yeah, we can flippity-doo-dah. You betcha we can flippity-doo-dah that. That's just beautiful. So we can still use this. Let me switch it on. And we should find that, yep, and picked up where we left off. Oh, look. Oh, that's it. I hadn't tried that. It didn't actually refresh the contents up there. That's interesting. Like it kept everything else, but it didn't refresh that. But when it's getting new data like it is now, I mean, if we go down a line, there we go. No, it's updated. But yeah, it cleared it. That's fascinating. All right, I know you want to see the rest of it. I can't remember how this differs from the... Well, yeah, no, I do believe this is very different from the 100. Yep. This is the revised model, thinner and lighter weight, double-sided load. Look at that. Wow, surface mount. The other one was all through-hole, wasn't it? Anyway, we've got some bodge wires and some bodge caps. The bodge wires look like big ground stuff. Is that an inductor or a diode? Not sure. You can see the red glue underneath the chips there. That's to hold them on. Yes, I remember this from the previous teardown. This is absolutely fantastic. This is some PCB routing perfection here. You'll notice that there's no markings on this chip. That's because it's mounted upside down. It's mounted in a cutout in the PCB. Why have they put one row of them like this and the other like this? This is for PCB routing reasons. Just the way that the pinouts worked, if you had these chips up the other way, like these ones, it'd all be higgledy-piggledy, and you'd need extra layers on your board to route it all. It'd be an absolute mess. So from a PCB layout elegance point of view, they've mounted these chips backwards with a cutout in the board. It's just, it's simply brilliant. It really is. Hats off. Luckily, we do have the service manual complete with all the schematics, the theory of operation, the whole works. They don't make them like this anymore, unfortunately. Tandy 102, custom manufacturer for Radio Shack, a division of Tandy Corporation. Oh, look at this. Look at this. Just a wet dream. Maintenance, disassembly instructions, theory of operation, troubleshooting. Oh, beautiful. I doubt, though, I actually haven't looked. I doubt they'll have a troubleshooting procedure for, like, this sort of fault in the LCD. But, yeah, you never know. Look at this. It's so comprehensive. Look at it. Look. Fantastic. Bobby Dazzler. Anyway, there's the back of our LCD board. And look at this. Ta-da! Here's the LCD driver board. Look at this. We have two rows here because this is a 40 column by 8 line LCD, and obviously each row of these chips here will be handling 4 lines, and we've got 5 for the columns, so 40 divided by 5, 8. Ta-da! Is it just simply this chip? Well, if I'm flipping it the right, whichever way it's, actually flipped, yeah, it could be M1 up there. That could be it. So, right off the bat, you would suspect this driver here, it's a Hitachi because they still dominate LCD drivers, don't they? I don't know, the standard Hitachi chipset. Anyway, the HD 44102 for those playing along at home. So automatically, you would either suspect this chip has failed or it's getting bad drive signals coming into it. There could be a chip select, there could be an address line, whatever. There could be some data corruption. But, it's obviously clocking. No, it's obviously getting the data in there correct. So it's got to be some sort of, like some sort of chip select thing. But it may not be that chip. It may be off on the main processor board, which actually drives it. There's the specs for those playing along at home. Look at this, 4 AA batteries. Last like 20 hours you can use this bad boy for. Unbelievable. Anyway, fantastic. 80C85 processor. So we've got theory of operation here, LCD common driver, LCD segment driver, LCD waveform, the block diagram. Yep. Okay, so an 81C55 drives into the LCD controller and then the LCD, but it also, it comes via the CPU bus as well, so it doesn't all come via the PIO. So the PIO is probably only driving the chip select lines and things like that. They don't make theory of operations anymore, do they? We'll get to there's the modem interface. I do want to do a video trying to use the modem on this thing. I think that'd be really cool. There's the modem connector interface circuit. I've done some experiments before in the past with, I can't remember if it was this 102 or the original 100, but yeah, anyway. LCD, here we are. The LCD using a Tandy 102 is composed of electrodes in a matrix arrangement, 64 common signals, 480 segment signals. This part is subdivided into 3 segments, the common driver, the segment driver, and the waveform. The common driver, here it is. That's the HD44103. Uses 2 common driver ICs. Okay, M11 and M12. Where was that thing we had before? So yeah, there's your common driver there and down there. I don't think it's going to be a common driver because, well, it's common. It's more likely to be the segment drivers. Now, I don't think we're going to have to go into the internal logic of the 44103 and the other common driver. I don't... it's just getting the wrong stuff clocked into it. I think that is the problem. It could be via any number of reasons. There could be a dry joint somewhere. One of the driver chips could be failed. Something could be wrong with something else could be loading down the bus, which is going to be common. Who knows? But yeah, I don't think we're going to have to get into that sort of detail. That's sort of like the last rabbit hole we want to jump down. Show us the schematic, Dave. Okay, after the bill of materials, here it is. Oh, isn't this just brilliant? Absolutely brilliant. Fantastic. Takes a second just to render a new, sharper version. But anyway, all the goodness, it's all down here. Right, so what we want, here's our LCD connector here, okay? Okay, well, I've got some CMOS logic doing some stuff here. Not worried about that yet. Let's have a look at the address and data lines here. Right, so let's follow this here, AD. So this is the data bus. It's not actually the address bus. These chip selects are the address. So if we follow the data here, okay, this comes over here. It's going, yep, it's coming. It's coming from here. Which let's not go there, but let's follow the money up here, up here, up here. Here you go. There you go. We've got a 245 there, and that's hooked into the 8085 processor data bus, right? So I don't expect there really to be any issue with the processor addresses and data buses because everything hangs off that, right? So everything else works. So I don't expect that to be an issue. So that's kind of like the last thing that you would look at here. So I'm not worried about the data bus there. All the data seems to be getting in. It's just getting latched wrong. So there's, looks like there's all these, well, thing is, it says chip select 1, 2, 3, 4 here. These ones have no label. So we'll go check the LCD schematic in a sec. But these come from PA0, PA1. So these come from, yeah, an 81C55 up here, okay? So that's being driven from there. So that's an I/O coming from the processor. So it's right into this, and then 4 of those lines are going into driving the LCD. And then other stuff, look, the read-write pin. So it looks like it can potentially read back. I don't know where S1 is coming from, or SI, but I wouldn't expect there to be any issue with the reset because the LCD is just working just fine, and I don't expect that, there's no problem with any of the voltage drivers or any of that sort of stuff, so all the enable here, so, you wouldn't bother looking at that. I don't know what this chip select here does, but, we're looking at one specific segment of the LCD, so there's nothing to see here. Move along now to the LCD schematic. They've got a nice looking LCD, and it's like, it's laid out very well. Look, like M1 up here is, they've done it, overlaid it into the specific thing. They've got information with driving the commons and the segments and the commons and stuff like this. Absolutely brilliant. So anyway, so this is looking face on like we saw, and as you saw, we were having problems in this quadrant here, the first 4 lines and the first 8 characters. Well, as we said, that's going to be controlled by M1 here. So what's coming into M1? Let's have a look. Tilt your head with me. Once again, I wouldn't expect any of like the voltage things to be a problem, because it's, the segments aren't faded, they're not doing anything like that, and they're all just, common with all the other chips. It's, it's not a problem. So it's, data going into this sucker. So it could be, I'd be looking at, the first thing I'd be probing, if I got the scope out, would be, we're probably going to have to, unless you just want to go, well, it's probably that one. And, if you had like an LCD swap or something like that to swap over, you might swap it over, and that it's nothing on the driving side of things, it's on the LCD module, and then you might go, well, okay, it's got to be this chip here, and then, but even if you do that, you've still got to like probe it to see, like, it could be a dry joint, it could be a bad solder joint, or one of these control pins or something like that. Once again, I don't think it's the data, because the data actually gets in there. You saw it as we were able to write into these particular segments. It's just that, the interesting thing is, when we were driving this one here in this bottom corner of the LCD like this, so if we were driving like line 5 here, line 1 would like duplicate the stuff on line 5 here. So when we're writing data to this, it's also appearing on this. And you might think, oh, okay, there could be like some short between, maybe there's some, I don't know, there's some tin whiskers or something happening, and there's a little short between, just throwing that one out there. You keep that in the back of your mind. But this is where you've got to like go back to here and look, no, all these other lines, all these chip selects are being driven. So I don't know why the labels were missing. They're certainly going up here. It's a bit hard to read, but you can see that's CS28 there, for example. So that's CS21. Oh, they're actually out of order. 6, 7, 1, 2, 3. So that chip, for example, is there, and that makes sense because we need 10 of them, okay? Because we've got 10 pins here, 10 chip selects, and we've got 10 chips total. So it's almost as if like the chip select for this one is short into the chip select for this one. Yeah, so we've got CS21 here, and this will be CS2 6. Yes, so okay, it matches the M1, M2. So yeah, we're looking at that line there and that one there. That's what's happening. So like, it's not like those two lines, I can't see how they're going to be shorted or whatever, but it could be something as simple as like an open line somewhere and then it's getting crosstalk from the other lines. So yeah, look, you can analyze this until the cows come home. You have a bunch of hypotheses and you just go in and check them all out. So let's open this sucker up. And I'd just start with just probing around here, for example, and just seeing, hopefully we can get access to the chips. I haven't taken it apart yet. Get access to the chips and probe them while we're actually using the thing. Otherwise, you got to like solder in mod wires to get test signals out and things like that. But first of all, we'll open up, give it a bit of a visual inspection, and then, we'll get probing. Anyway, there's our suspect up there, M1. So what I'm going to do is I'm going to have get that under the microscope and have a good look at it, do the visuals, looking for any, dodgy solder joints, any hairline cracks, any bridges caused by tin whiskers, for example, which, a growth over time. They can grow out and short out pins and stuff like that. Just generally have a squiz. And you can just really see it quite clearly here, how it just duplicates. It'll go to the next line. Look, it'll shift that up. Check this out. I wonder why they've exposed the solder mask along there. Just a little slither there. It's interesting. They've done it on every chip. Like this one at the top here. It's got it on all 4 sides. Look at that. And you'll also notice on the board here how they've got all these traces running off the edge of the board like this. Up here, they've got... Up here like this, they're just buggering off over here. One of the column drivers over here just goes off, the even down these signals down here. Why are they doing that? Well, that's probably for some sort of production panel testing would be my guess, and then they shear the things off, they route them off later. All right, let's have a look. M1, that all looks pretty schmick. Not seeing any tin whiskers or shorts or anything. Might want to go over this, see if there's any bad solder joints. Like as in physically not soldered, see if I can move any of these pins. They're all looking pretty good. Nothing's loosey-goosey there. Really is no issue there whatsoever. I mean, it could certainly be the chip. Like, I would not rule out the chip. Hang on for a second. I was just looking for a place to probe, and I was looking at the pins I'm interested in down here, and I see a little dag. Hello, Mr. Dag. I'm actually going to measure between these two pins and see what's what. Can't be that easy, surely. Those two pins... Oh, no, 125 ohms. My meter's beeping at 125 ohms. I'm going to get rid of that dag. Nah, it's still 125 ohms. I think that's a nothing burger, but geez, that was coincidental. Okay, it's probing time. What I did is I just soldered a little 0.1 inch header pin onto the ground pin there, which is pin 5, and pin 6 is ground, so that just allows me, there was no other like convenient ground point, unfortunately. And I'll include the schematic here. So what we're looking at, we want to probe the chip select pins. That's like definitely the first port of call. So we're talking pins 16, 15, 14, CS21, pin 14. That's the culprit that we actually want right there. So pin 12, 10, 8. So, you know, there's a whole bunch of, they'll be on this side of the connector over here. So it's working, it's powered up. So 2, 4, 6, 8. Wasn't one of them pin 8? I think. There we go. We're getting bus activity, 5 volts. And, yep. Yeah, if I press the, like, just pressing the enter key. 10's doing nothing. Okay. Oh, no, sorry. I just wasn't probing it properly. You got to get through. You might have some flux on the pins or whatever. Always good to have sharp pointed probes to get through. If you ever, that's a tip, like ever have, like if your signal's missing or something like that and you think, oh, there should be a signal there, what's going on? Don't chase that red herring down a rabbit hole. Just check that you're actually piercing the, like any flux or any other contaminant on the joint, that you've got a nice sharp pin. That's number 12. Yeah, so all these chip selects, they're all working. Now 14. This is the bad boy. Hello. 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 Number 14. Yeah, I'll push really hard on that. Yep, number 14. Let's go to 16. Yeah, 16's there. Bingo. Winner, winner. Chicken dinner. We found it. Exactly as I suspected. Yep, pin 14 there. CS21, which drives our M1 chip, which drives the quadrant up here, which is the chip select for this chip up here. So obviously, it's now the chip select on this one here is just flapping around in the breeze. It's just floating. So it's picking up crosstalk from basically everywhere else. So that's why it's like latching in the same data. You know, it's because it's a common data bus among them. So they're all getting the same data. So there's no wonder that this chip is shifting in the same data as you're typing in over here somewhere, for example. So it's, yeah, the chip select is just, you know, it's been enabled. I think the read-write will be all the same. They'll all be the same, right? So it's writing the data. It's only the chip select that makes a difference between these chips. And this sucker is floating. So that means our fault is actually on this board, or it could actually be on the ribbon cable. It could have like a broken ribbon cable or something like that. Yeah, it may not be electrical fault at all. It may be a mechanical job. Or we could have a bad contact on the ribbon cable. The first thing you do is just reseat the ribbon cable on both ends. Okay, those contacts look pretty shiny. No wuckers there. Let's plug it back in. Nope, same problem. It's not that. It looks like the drive side or the other side of that connector. So unfortunately, this ribbon cable goes through the board here, so I'll have to take out the entire board. Well, not unfortunately, it means we get to look at the other side. There you have it. There's the rest of the board. Yeah, it's still all through-hole jobs, mostly, although we do have some surface mount. I don't think the previous version had any surface mount apart from the LCD, did it? But I could be wrong. Anyway, yeah, there's all our modem stuff out there. There's our isolation transformer for our modem. And the 8085 made by Oki in Japan. All the best stuff's made in Japan. 81C55 is down here. And there, that chip contains Bill Gates himself. Copyright 1983 Microsoft. So yeah, that's the ROM is soldered in. Let's measure our backup battery there. Sorry, you can't see it. 3.42 volts. Oh, that's still pretty good. And again, there doesn't appear to be any corrosion on the contacts at all. Nothing doing there. Plug that back in. And I've reseated that, and nope, same old, same old. So, you know, good thing about this is you can actually get this right out and work on the bench. I mean, look, we can actually, it's actually better to work on it now on the front of the board like this, because we can just have our LCD just facing up. Fantastic. Oh, that is probing heaven. Beautiful.
Beautiful.
Good thing is that we can actually probe the top of this connector, because the even numbered pins actually come out over here. So let's go pin 14 again. 14. Ta-da! There it is. Same problem. All right, so it's not the cable at all. It's not the ribbon cable or the connectors or anything to do with the LCD. It is definitely coming from drive on the circuitry, although I haven't inspected the solder joint. Now, hang on. Check this out. Pin 2, 4, 6, 8, 10, 12, 14. That trace going through there, what is that? Gouge? There is no way that is a coincidence. Is that some sort of like gouge chunk taken out of there? That's way too much of a coincidence that it's there. I'm going to get that under the microscope. There's no way that's a coincidence. Has that been reworked? I don't know. But look, come on. That's not a coincidence, is it? That looks black. That looks like it's rotted away or something. Am I wrong? That looks dodgy as. Let me buzz it. Hang on, I'll see if I can get, yeah, there we go. That side, right? But it won't go over to here. Yep. There you go. Winner, winner, chicken dinner. Found it. It's a track. Wow. Wouldn't have bet on that. A track on the main board that's somehow, like, corroded away. I don't know. And these chips, you tell me, has that been... I'm looking at, like, the other chips on here. They don't have the same flux residue on them. I reckon this has probably had a repair done to it. Just looking at some of the other chips out, you know, these don't have any of that, because this is all wave soldered. That's why it's got the glue, although that one still does have the glue under it, look. So, not sure what the deal is. Yeah, it's actually corroded away. Let me clean that up. Not entirely sure how. I have to lift my microscope up here, because it's designed for, like, because the board's too high. So, at extreme zooms like this, but look at that. Yeah, there's some sort of corrosion that's got into that, and that's eaten through that poor little track. But that was it. I found it by pretty good deduction there. That was one of our hypotheses, that the chip select was flapping around in the breeze, maybe. Was just getting crosstalk from something else. And that turned out to be the case. So yeah, all I got to do is fix that. Should be as good as new. Let's just scrape away some of the solder mask on the pad there. And this is post-editing Dave here. Yeah, my capture froze. I'm going to probably replace that with a hardware capture solution soon, like dedicated hardware, like a Blackmagic's ATEM probably. Anyway, little jumper link. Yes, we have a winner. Winner, winner, chicken dinner. There it is. No worries. Basic, January 1st, 1900. Yeah, Y2K bug. Yeah, it didn't end the world, though. Trust me, that was a thing. Those who remember the Y2K bug, oh, geez, I was the Y2K engineer at, was it Tally's or Surcell? No, it was probably Tally's Australia at the time. And yeah, I had to go around and certify that everything, I'm talking every little pissant project that contained a microcontroller or anything that had no real-time clock in it, I would still have to write a report certifying that it was Y2K compatible. Anyway, basic, ta-da, TRS-80, Model 100 software, copyright 1980, because you want to save a few characters. Every character was precious. in 1983. Microsoft, Bill Gates himself might have written that. 29,382 bytes free. Done. Fantastic. Winner, winner, chicken dinner. Hope you liked that repair video. If you did, give it a big thumbs up. And as always, you can discuss down below. And catch me on Odyssey and all the other platforms. You know what to do. Catch you next time.